All right, this lesson is 4.3 in your textbook. If you're following along, Pre-Calculus 12, McGraw-Hill Ryerson textbook, page 191. And what we're going to talk about is the unit circle and trigonometric ratios. Okay, so we talked a little bit last lesson about our special angle triangles, right? And we also talked about how those special angle triangles, what they would look like, what the dimensions would be if they were to fit right inside the unit circle. And that's kind of where we launched off. So what would the dimensions be for those special angle triangles if they looked like this, with a radius or a hypotenuse of 1? So that's kind of where we started off yesterday. And we figured out that if this is a 45 degree angle right here, and this was 1, then this height and this length right here would obviously be the same. X and Y would be the same. And who remembers what value that would be? Square root 2 over 2. Yes, square root 2 divided by 2. So root 2 over 2. That's what this coordinate is. X value of root 2 over 2, Y value of root 2 over 2. So that's kind of where we went. Now, let's come back to the notes here. What we're going to talk about more specifically is trigonometric ratios and how that has to do with the unit circle. So the trig ratios, do you remember what the primary trig ratios are? Okay, SOHCAHTOA, yes, that is a memory mnemonic that helps us understand what those ratios are. So you mentioned SO, Ka, and TOA, yes, we're going to need that here in a minute. So the primary trig ratios are the sine, cosine, and tan. Okay, so sine, cosine, and tangent. Of course, we abbreviate those primary trig ratios as sine, that's S-I-N. Cosine is cos, C-O-S, and tangent is tan. All right. Now, the other thing, when we talk about trig ratios, talking about them on their own, just like this, like sine, cos, tan, makes no sense at all. It is meaningless unless you have some sort of angle that we're talking about, okay? So the trig ratios are actually these ratios, and they do have something to do with the sides of the rectangles, the sides of the triangles that these angles are included in, but we always have to have some kind of angle attached to it or else it has no meaning. Now, you mentioned SOHCAHTOA. I like that because we are going to be using SOHCAHTOA in understanding the intense and amazing usefulness of the unit circle. Consequently, I did get you to fill out a blank unit circle the other day, and it is going to be very important for you guys to memorize the unit circle. I know, but listen, remember that all of these values right here, especially these ones, this is all you have to memorize. That's it. 30, 45, 60 degrees, you have to memorize those. And you have to just memorize these pairs of numbers, which there's only 3 numbers to memorize here, because they show up in the other quadrants as well, just with different signs. So you don't want to have to be referring to your unit circle over and over and over again for every little thing. You should try and memorize as much of it as possible. And again, if you focus on quadrant number 1, you pretty much have the whole thing memorized. So just a challenge here going forward. Now, what I want to outline, though, on the unit circle is this. The radius being 1 is super important for connecting the trig ratios with the unit circle. So let me just outline this. I'm just going to draw this. It's a 45, 45, 90 triangle, right? So this angle theta is 45. So let's say I wanted to talk about the sine, the cosine, and the tangent of 45 here. Make that in red again. Of 45 degrees. And of course that in radians is pi over 4, right? So we could write 45 degrees or pi over 4. It means the same thing. But if I wanted to explain what sine of 45 is, I would then have to look at the opposite side of the triangle that it's contained in and the hypotenuse of the triangle that it's contained in. So let's take a close look here, because this is going to be super cool. All right? sine of 45. That is the opposite side over here. That's the y coordinate of this point. If you notice, the opposite side, divided by the hypotenuse. And what is the hypotenuse in the unit circle? 1. So opposite side is y, hypotenuse is 1. So the sine of 45 actually equals the y value of this point right here. Okay? The y value of that point. And look at this. The points are right here, because we're going to memorize these. They're right here. You notice that the y value is root 2 over 2. So let's just get on our calculator here. Let's just confirm some things. Okay, let's get out of there. All right, what am I in, radians or what? I am in radians. Let's go over to degrees. And let's just say, what is the sine, Mr. Calculator? What's the sine of 45? 0.7071. I think we decided yesterday that that actually is root 2 over 2. Yeah, okay. So, the unit circle, look at that. These coordinates are important. Now let's take a look at cos of 45. What is cos of 45? Well, cos is the adjacent side divided by the hypotenuse. So the adjacent side is going to be this side, and that's going to be your x value. So it's x over 1 in the unit circle, which is just x. So let's just check out here, because it looks like if that's true, the x value here is root 2 over 2. So cos of 45 should be the same as sine of 45. I don't know, is that even possible? Let's give it a check here. Cos 45 is my Lanta. 0.7071. Look at that. Like my mom used to say, oh, my stars and little pussycats. I have no idea why she said that. Yeah, that was like it's like almost an expletive. That's about as close as my mom got to swearing. Oh my God! I don't know. Anyways, so that's me being flabbergasted. Look at this. It's the same. And the connection to the periodic table. Excuse me, math. The connection to the unit circle. I've called it the periodic table actually quite a few times. Is that the coordinates on the unit circle, because the radius here is 1, that means the hypotenuse will always be 1. The coordinates x and y, x, y, they're actually cos of whatever angle that point is connected to, and sine of whatever angle that point is connected to. So this is huge right here. We should write that down everywhere you can. But these points, okay, cos theta, sine theta. All right, so tan is the only one we haven't dealt with, but who remembers what tan, how tan can be defined? Anyone remember how tan can be defined? Anybody remember? Ladies, paying attention? Tan is opposite over adjacent. That's true. Does anyone remember at all how you can define tan? I don't know if you've ever been told this or you know this. Anyone know? No? Okay. Watch very carefully. Watch very, very carefully. Tan, we know, is opposite side divided by adjacent side. So for 45, what's the opposite side? Y. What's the adjacent side? X. What is y? Y is not 1. Y is sine. What is x? Tangent, if you didn't know this before, tangent theta can be defined as sine theta divided by cos of the same theta. That, you guys don't know that, eh? That's your first time for that? First time seeing that? Nice. I counted a privilege to be part of your inaugural learning of this fact. But that's where it comes from. Look at that. That's where it comes from, you see? Cos is x. The x value here is cos. So really, you can express tan as a ratio of sine over cos. Now, for tan of 45, right, this is sine of 45 degrees over cos of 45 degrees, which is root 2 over 2 divided by root 2 over 2, which if you have something divided by itself is 1. So tan of 45 is 1. Can we confirm that outside of the unit circle? Well, let's draw our special angle triangle, 1, 1, root 2. You know that for 45, right? That's where we started. So tan of 45 should be opposite side divided by adjacent. Look at that. Tan of 45 is 1. On our calculator, let's see if the calculator will tell us the same thing. Hello, Mr. Calculator. Please tell us what the tan of 45 is. Oh my land thought. Oh my star of the little pussycat. It's amazing. Okay, tan of 45. Okay. Now, here's the thing. Here's the thing. This not only works for 45, this works for 30, 60, 90, 120, 135, any of these. And the unit circle will give you exact values of many of these angles. Not every conceivable angle, but many of the angles. You will be able to get exact values right from the unit circle. Okay? So again, once again, not every angle, but for many angles. So what is the cos of 225 degrees? Do not get out your calculator. No. You have not been listening, have you? What is the exact value of cos of 225? Now we look at our unit circle. What is it? Let's see. Cos of 45, yes, is root 2 over 2. So what about the cos of 225? Here's 225 down here. So what's the cosine of 225? You don't have to look at adjacent over hypotenuse. You don't have to do any calculating. Okay. Okay, negative root 2 over 1. Now, here's the thing. Now, just listen. Here's the thing. You don't have to do all of the division. You don't have to do SOHCAHTOA. Okay? You don't have to. Because look at, what did we just say up here? The x value is the cos. You don't have to think about SOHCAHTOA anymore when you're talking about the unit circle. Okay, you don't have to do it. 225. Look at the point that is associated with this angle right here. It is negative root 2 over 2, negative root 2 over 2. The first coordinate is cosine. That is the cosine ratio. That's it. So you don't have to do SOHCAHTOA. You simply look at the circle. Negative root 2 over 2. Double check on your calculator now if you want. Right? Cos 225. Negative 0.7071, that's root 2 over 2. All right, we getting it so far? Getting it? Is it same for the 30-60 triangle? Yeah, everything works the same. Do you mean like this over here? Okay, so let's go back to our original 30-60, 90 triangle you're saying. So this is 60, this is 30, really messy. 1, 2, root 3, right? So cos of 60, let's say, should be adjacent. That's 1 over what? Hypotenuse, which is 2. Should be 0.5. So we go up to our unit circle. Here's 60. 1/2. Okay? So we talked about exact values. Let's formalize that. Do you guys know what exact values are versus approximate? We talked about that with you guys? Did we do that in class here? Okay. So exact values, I missed an X there. Exact values, we're talking about radicals, right, with roots, not decimals. Okay? Sorry, I'm just going real fast here and kind of being messy. But exact values have radicals. They have roots in them. They're not decimals, because as soon as you write a radical as a decimal, you're rounding it off. That becomes approximate. So approximate values would be the decimal versions, okay? Decimals. So the textbook will mention, give me the exact value, because in pre-calculus, we're interested in exact values, believe it or not, because when we're talking about calculus, We're talking about an infinitesimally small, thing, and we want to know what the exactness of that number is. We don't want to round, because if we're talking about, approaching a number, and we're talking about an infinitely small distance away from the number, we're pretty concerned with the exactness of the number. So we would never write cos of 45 as 0.7. Don't ever do that. You would write it as root 2 divided by 2. Got it? Exact versus approximate. Okay. Using your unit circle only, what about this one? What is the sine of negative 3 pi over 2? The sine of negative 3 pi over 2. Go ahead and give that one a shot here. Who's got an answer for sine of negative 3 pi over 2? Well, first of all, we got to find negative 3 pi over 2, right? Here's 3 pi over 2, but in the positive direction, it would look like this, right? That's positive 3 pi over 2. So negative 3 pi over 2 would be going 1 pi and then another half pi this way. So really, we're talking about these values over here. Negative 3 pi over 2 is going to be the same as sine of pi over 2. So these points right here, even though they're not crazy irrationals like this, 0, 1, this still represents the cos and sine. So remember, it's cos first, think alphabetical, and then sine next, okay? Yeah, think alphabetical, that's what I do. So the sine of negative 3 pi over 2 looks like it should be 1. Did anyone put 1? Let's test that out in our calculator. Let's just try. See, sine of, that's going to be negative 270 in degrees, right? 1. Okay, unit circle. Unit circle is our friend. 1. Now, what about the tan of pi over 2? What's the tangent of pi over 2? So we're still looking at this area right here, right? And how did we define tan again? That's going to be the sine of pi over 2 divided by the cos of pi over 2. Is that right? Sine over cos, remember? So if we look at our coordinates here, sine is 1, cos is 0. So what is 1 divided by 0? Yeah, undefined. Okay, so you get to this point, you can just say it's undefined. Okay, yeah, there's an asymptote on the graph. Yeah, just undefined, no real number. So tan of pi over 2 is 1 over 0 or undefined. And let's just see what the calculator says about that. So tan of 90 degrees is error. Go to the error. That's your problem. What about 900? Is that going to be better? Ooh, 900 is 0. Where's 900 on this graph? Anybody know? What's this? 360? What's 360 plus 90? 360 plus 90 is 390. 450 plus another 90 is 540 plus another 90 is 630 plus another 90 is 720. Okay, we're good so far? 720 plus 90 is 810. 810 plus 90 is 900 degrees. So 900 degrees has the same values for sine and cos and tan as 180 degrees. So when I did tan of 900, and that equaled, was it 1? What was it? Oh, 0, sorry, 0. So what that means, sine over cos. So that is, sine is, according to this, 0. Cos is negative 1. What's 0 divided by any constant other than itself? 0. See that? All right. So we spent a lot of time developing that. The primary trig ratios, okay? Um, the unit circle, very, very helpful. There are some primary trig ratios that are undefined. Okay? All right, reciprocal trig ratios. Reciprocal trig ratios. What does reciprocal mean? Flip, thank you. So if I have sine theta, the reciprocal trig ratio for sine theta is 1 over sine theta. Does anyone know what this is called? 1 divided by sine theta? Does anyone know what that trig ratio is called? No? Never seen this before? All right. Anti-sine? No. Good guess, though. It's not right, but it's a very good guess. It's actually cosecant. What? I don't know. I wasn't asking you to guess it correctly. I just want to know if anyone knew. Cosecant of theta. Okay, 1 over sine. Now, what about 1 over cos? Now, think about this now. What's your guess? Secosint? Very close. Secant. Secant theta. What about 1 over tan theta? Tangent? No. Cotangent. That's a little bit more reasonable, isn't it? Cotangent. Okay, so these are the reciprocal trig ratios, and literally, they are the reciprocal ratios. So whatever number sine is, like for example, sine of 45, what did we say just a few minutes ago that is? In exact values, of course. Thank you, root 2 over 2. It's pretty quick. So the cosecant of 45, cosecant of 45 degrees is what? It's 1 over this, or 2 over root 2. Or you might also see it in simplified form as what? 2 root 2 over 2, which is root 2. Complaining and whining. What am I doing? Really? You guys don't know what I'm doing? Oh my gosh. Really? You guys weren't paying attention to like physical science? Or physical science. Pre-calculus 20, foundations 10. You easily forget things. Great. That's awesome. Okay, whoa, wait. Simplify this. You don't know how to simplify this? Remember, if there's radicals in the denominator, that is technically not simplified fully. So you multiply top and bottom by the radical that's in the denominator there. That's how I get 2 times root 2 over root 2 squared, which is just 2. Then you simplify those to become root 2. No? Okay. How do you write cosecant as an abbreviation? Anyone know? Close. CSC. Cosecant 45. Okay. So cosecant is CSC, secant is SEC, and cotangent is COT. Those are the abbreviations there for the reciprocal trig identities. So obviously, you can get the reciprocal trig identities from the unit circle as well, right? So let me copy this again. All right. So what is the, let's just do a little test here. So what is the secant of, oh, I don't know, 300? The secant of 300 degrees. So you gotta look for 300, which is down here. And secant is the reciprocal of what? Cosine. So where's the cosine here? Is it the first one or the second one? First one. So what is the reciprocal of 1/2? The secant of 300 is 2. Now how do you do that on your calculator? How do you do that on your calculator? You do not do, don't do this. Don't do second function cos. Okay, that's not the same. That is not the same as secant. Okay? On your calculator, what you have to do is you have to do 1 divided by cos of 300. That's how you find secant on your calculator. Look at that. 2. Okay? Reciprocal. Do you guys want to know how you remember which reciprocal function is associated with which primary trig function? there's always a co with a no-co. Co with a no-co. That means if we have sine, it's got to go with co-secant. See the co? If we have a cosine, that always goes with no co-secant. And if we have tangent, that's got no co there, it's got to go with a co-tangent. So here's no co and co. Here's co and no co. Here's no co and co. They always go together. That's how you memorize that. All right, so the final little bit of this lesson, CAST rule, C-A-S-T. This rule tells us which trig ratio is positive or negative in which quadrant. So it attaches the trig ratio or ratios to a quadrant, and it tells you really quickly whether they're going to be positive or negative. Okay? Now, the coordinates in quadrant 1, here's quadrant 1. The coordinates for any point in quadrant 1, the sine, S-I-G-N, are going to be positive and positive, right? Positive x value, positive y value. So, cosine, sine, and tangent are all positive in quadrant 1. Okay? And there is your A value. That's the A in CAST. What about over here? What about this one? This quadrant right here. The coordinates for any points would be negative x value, positive y value. So that's going to be a negative cos, it's going to be a positive sine, and it's going to be a negative tan. So which one is positive? Sine is positive. And there's the S value. Okay. So what about the third quadrant? Well, these coordinates are negative, negative. So cos is negative, sine's negative, but tan is positive. Okay, so you see how the CAST are coming into play? Over here, the cosine is positive because of the coordinates plus x minus y down here. So the cosine. Now, if you think about the CAST rule and start in quadrant 4, C-A-S-T, then that's how you can remember which trig functions are positive. That's what it tells you. And of course, I'll finish this off. Quadrant 1, quadrant 2, you know that. Quadrant 3, quadrant 4. So that's finally the CAST rule. If you know which where an angle terminates in which quadrant, you automatically know the signs, S-I-G-N's, of the trig ratios. Okay? So like, what's the cosine of 880 degrees? Is it positive or negative? Which one is it? You remember we just talked about 900 in this lesson? What is it? Negative? Okay, you have a 50-50 chance, I guess, pretty much. But yeah, does everyone agree with that? Can you tell us why? That's right. So that's where 880 would end, and it's in this one. So sine is positive. That means cos must be negative. Very good. So there's a little thing you can that'll help you sort of, you know what the value is. And the other thing is too, just look at the values. The unit circle actually tells you that. Look at cosine is negative here, but sine is positive. Sine is positive here. Over here, these are both negative, so tan, when you divide negative by a negative, that's positive. Here, the first coordinates are positive and so on. Okay? So the unit circle tells you that already. All right. So, big lesson, chock full of information. There's lots of stuff there. I apologize that it's so big. But anyways, this is a huge deal when we talk about unit circle, trigonometry, exact values, trig ratios, and all that sort of stuff. Okay? So there's your massive lesson on 4.3, trig ratios and the unit circle.